In this video, we're going to look at example 3, where we evaluate expressions with rational exponents. So we're asked to evaluate the expressions 32 to the 3/5, 27 to the negative 2/3, and 50 to the 3/4. And these are three separate problems, they're not combined. So let's start with this 32 to the 3/5 power. And what I want to point out here is what I mentioned in the last video. There's two different ways we can write this. I can change this to be the 5th root of 32 cubed. Let's fix that 3. Or the 5th root of 32 and then cube that expression. You'll get the answer for both of them. All right, you'll get the same answer no matter which one you pick. However, I, again, do not want to do 32 to the cube power and then try to take a 5th root of that. If I have a calculator, yeah, that's not too bad. Obviously, I can just type in whatever numbers I want and it'll get me the answer. But in this case, let's say we're doing this by hand. All right. So the 5th root of 32. As you get better at these and more familiar with them, you'll start to be able to kind of jump to the answers. But we're looking for something that times itself 5 times this gets us to 32. Clearly, larger numbers are out of the picture, so I'm going to test 2. And I want to know, does 2 times 2 times 2 times 2 5 times, does that get me to 32? Well, the answer is going to be yes. All right, so this would be 16 times 2, which would be 32. That checks out. So the 5th root of 32 is 2. And then 2 cubed would be 8. And that's going to be my answer. All right, pretty simple and pretty easy once you get the hang of these. Second one, we have 27 to the negative 2/3 power. All right, now what's different about this one? They're just throwing a negative into my exponent. So we're going to treat that the same way. All right, so this is going to be the cube root of 27. This time I'm going to put the negative 2 out on the outside there. Okay. So the cube root of 27, what times itself 3 times gets me 27? Well, let's check. But 3 times 3 times 3 looks like it's going to be 27. So this is going to be 3 to the negative 2nd power. Hopefully you remember your rules of exponents from Algebra 1, Algebra 2, parts of it, depending on how much of this you've done before. But anything to the negative power, right, this is going to become 1 over 3 squared, which is 1 over 9. And that would be my solution. Remember, a negative exponent is going to cause our term to either go from the numerator to denominator or denominator to numerator. And then finally, we have 50 to the 3/4 power. So this tells me to take the 4th root of 50 and then raise that to the 3rd power. Now, for this specific problem, there is no perfect 4th root of 50. I already know that, but if you try to figure it out, you'll realize that 2 obviously doesn't work. 3 times 3 times 3 times 3, that's not going to work. 4 won't work, 5 won't work. None of this is going to work. So since we're trying to do this by hand here and there's no perfect root, we don't have any option other than to use a calculator. So if we do use a calculator, this specific problem, 50 to the 3/4 power, is approximately 18.8. Okay, so in this specific case, there's really nothing we can do about this. You're definitely not going to be able to do the 3rd example by hand, but the idea is at least try to set it up and get used to changing, these fractional exponents to your radical expressions. And if you can do that, you'll be able to solve most of these. Occasionally, textbooks like to throw problems at you, like this 3rd one where you can't actually do it. But most of the examples you will get should look like the first 2. And that's it. Just practice rewriting these fractional exponents.